the time for the preparatory exams that are coming very soon, and I hope you've read enough. Now we just need to go through the guidelines and see what is expected of us. So geography, it has got two papers. Where we have paper 1, and paper 1, it does include climate and weather. Let us wait for technology. It is just getting ready. Yes, just getting ready. All right. Sorry about that. So I was saying geography, it has two papers. It has paper 1 as well. It has paper 2. Where's our paper 2? Paper 2 is way down this side. This is our paper 2 here. Right. However, let us first get familiar with paper 1 and see what we are expected come preparatories this week or this month. What are we expecting? What is expected of us, and all of that. All right, so paper 1, it has climate and weather, the main topic. And what do we expect under climate and weather? We have the mid-latitude cyclones, which other names can as well be referred to as the frontal depressions, extratropical cyclones. So you need at least under mid-latitude cyclones, you need to understand areas where they develop, between which latitudes, areas which they affect, which season do they occur, and all of that. So those will fall under the general characteristics. Areas of formation, like I mentioned, we can talk about the polar front, talk about forming between 35 to 60 degrees north and south of the equator. Talk about a form where the polar cold easterly winds meeting with the subtropical warm westerly winds. So this could be under the areas of formation. Conditions for their formation, like I believe this could include the polar front, the different air masses, that is the polar easterlies and the warm westerlies, stages of development, including the wave stage, the formative stage, the mature stage. We have the occlusion stage and as well the dispersion stage. So that falls under stages of development. And as well, you could be asked to draw a cross section through a mid-latitude cyclone. For example, if you try to put a structure here of, if you try to put a synoptic showing structure of the mid-latitude cyclone in the mature stage, we have the cold front there, we have the front. So they might ask that draw cross section from A to B. Of course, A to B, this includes the whole of the mid-latitude cyclone, which means we need to put our cold sector, the cold front, the home sector, the front, and as well the cold sector this other side. And also we indicate the direction of air movement. However, also need to be very careful where they could ask you to draw cross section, for example, between A to X. And as you can see, this is a warm front. So be very careful there, meaning When they say A to X, if they say a home front, we do not expect you to include the cold front or the whole system. Or it could only be between, let's say, M and N. And as you can see, M to N, that is a cold front, which as well does include the cold sector, the cold front, and part of the warm sector. So basically, that is about if they are to ask you regarding the cross-section of a mid-latitude cyclone. As well, you need to understand the cold front conditions, the warm front conditions, and the occluded front conditions. When they say the cold front conditions, they could ask a question, for example, identify the weather conditions that will be experienced, let's say at Cape Town, when the cold front approaches, or to describe the weather conditions that are associated or that are accompanied by the warm front or the occluded front conditions. And don't forget, occluded here, we are looking basically the occlusion stage, where we see the cold front catches up with the warm front. So this normally occurs in the occlusion stage. All right. Then we proceed down to the impacts on human activities. So we need to be very careful to ask about the social impacts. These are impacts regarding our daily way of living, and economic impacts, how they affect more of the business activities or the environment. Like environment here, talk about soil erosion, ecosystem, natural habitats, flooding, all of that. So all those could fall under the environment. In economic, talk about infrastructures being destroyed, communication and transport being destroyed, talk about daily activities being disrupted, etc. In social, how they affect our daily lives. For example, at times when they are cold fronts, especially the cold snaps, you're going to experience those strong winds, very low temperatures that could cause maybe people to catch cold or flu, etc. All right. Then talk about the possible precautionary management or measures, what need to be done to reduce on the effects of the mid-latitude cyclones. Remember, we cannot avoid or we cannot control its formation or occurrence. However, we can try to reduce on the impacts that are caused by the mid-latitude cyclones. So that is why here they do talk about the possible precautionary and management strategies. What can be done to reduce the impacts that are associated with the mid-latitude cyclone? For example, we could mention about evacuating away from areas that will be affected by floods, or move away from low-lying areas, buying warm clothes, etc. Then they can as well ask a question regarding identification on a synoptic, weather maps, and satellite images. Now, this is very crucial, and they love more of this question here, where it means you need to understand how to interpret a synoptic weather map. All right, so here they talk about the synoptic weather map. For example, we can check here. So this is the synoptic weather map. As you can see, they're saying I didn't see anything there. I think there were questions here where they were saying refer to 1.1 an extract from a synoptic weather map. So please need to be very, very careful. Firstly, the synoptic weather map showing mid-latitude cyclones, as you can see here. This is our mid-latitude cyclone. So you can see this one is in the occlusion stage. You see? So we need to be very careful, and they could as well, so they could ask so many questions in which stage, movement, or which season, and all that. So this is how a synoptic weather map looks like for the latitude cyclones. Right, so we need to be able to as well, they say, identification of stages of development on a synoptic weather map, like I just mentioned. Here they talk about they also they're able to show the different stages. As you can see, like I mentioned, this is an occlusion. You can see this is the warm front and this is the cold, and automatically this becomes an occlusion stage. And you can as well say, there is there's a cold front, there's warm front. Cold front, warm front, which means that you can find this as a mid-latitude family, right? Then we proceed down to the impact of South Indian High and South Atlantic High on the movement of the cyclone, where sometimes they say, or they can ask you that, can you see this is the South Indian High, this other side, which can act as a blocking high for the mid-latitude cyclone, because we know the MLC moves in this direction. However, where it is moving, you can see the ridging of the South Indian High, which means it does block the mid-latitude cyclone from continuing, which means it has to change the direction. Therefore, so we need to understand the impacts of the different high pressure cells, and reading and interpretation of the weather symbols predicted weather impact. So the symbols, this could include, for example, talk about the cloudy cover, which is overcast here, the wind speed, which is 10 knots, here it is 30 knots. So there are 3 lines indicating 30 knots. The wind direction here, it is north. So also you need to understand those different weather conditions. Then that is still in paper 1. Also, they could ask you about tropical cyclones, their general characteristics, including where do they form, movement, moving from east to west, rotate clockwise in the south and anti-clockwise in the north, develop over warm oceans driven by the eastern winds, etc. Areas of formation and associated terms in different parts of the world. Like here we say, when they say associated terms in different parts of the world, where we know in Australia, they refer to as willy willies. In Asia, referred to as typhoons. In Africa, tropical cyclones. In America, hurricanes. So that's how they're being given different terms in the different parts of the world. To talk about factors necessary for their formation, these are the same as the conditions for their formation, including the Coriolis force, upper air divergence, high temperatures, latent heat, among other factors. So, about factors for the formation, then stages of development, where we have the formative stage, the mature stage, and as well the dispersion stage. So, but you need to take note of the mature stage and the dispersion stage because they are more examinable, where in most cases they might ask you regarding factors that makes a cyclone to dissipate. When it comes to the mature, they could ask you to explain factors or to mention or to describe factors which makes a cyclone, So we need to understand the various stages and as well how to identify those different stages on a synoptic weather map. Then the associated weather patterns, the different conditions, then the cross-section of a tropical cyclone. So we need to as well know how to draw cross-section, for example, showing the tropical estuaries converging. Then after that, you're going to ascend, and there will be upper air divergence. You're going to have air descending in the eye. They talk about the clockwise rotation or anti-clockwise rotation. See? Yes. As well, under tropical cyclones, identify different impacts on human activities, social and economic, or the environment. How do they affect us socially, economically, or on the environment? Then the measures that can be put in place to reduce the effects of tropical cyclones. Remember, when we talk about the precautionary management strategies, here we cannot prevent a cyclone. But what do? We can try to reduce on the effects that are associated with the tropical cyclone. Then also need to identify identification on a synoptic weather map and satellite images. So we need to be able to identify the tropical cyclones on the different maps and as well as satellite images. This way to check if you can find one tropical cyclone image. Yes. Now this is a typhoon. They're saying here. Okay, let's try to. This is a typhoon. Of course, like we mentioned, there are called different names in different areas. Then we have identifying the different stages of development, reading and interpreting of the applicable weather symbols, etc. Then from the tropical cyclones, then we go to the subtropical anticyclones, or the same as the high pressure source. There's rainfall, overcast conditions as a result of the inversion layer being uplifted above the escarpment. Then winter, it causes clear skies, less rainfall due to strong subsidence, pushing the inversion layer below the escarpment. Then reading and interpreting of the information are routed to the three pressure sources. Here they can ask you their positioning. Like we know, the South Atlantic is situated to the west of Africa, South India to the east of Africa, then continental or the Kalahari situated to the over the land of Africa. Then development of the traveling disturbances associated with anticyclones, about the moisture front and line thunderstorms, the coastal lows, and the South Africa big winds. Then under the big winds, moisture fronts, the coastal lows, like we know, big winds develop as a result of the presence of the coastal low and also the presence of the Kalahari high over the interior. Then the moisture front, which does develop in summer as a result of the thermal low or the heat low pressure soil dominating over the interior. and the presence of the two high pressure zones, including the South Atlantic High and the South Indian High. Then as well, you have to look at the different conditions that are associated with these different conditions, like big winds. We know when the big winds, they cause the air to rise, the air temperature to rise, or result into clear skies as a result of the subsiding air, because we know whenever the air subsides, it warms up diabatically, losing all the moisture, and there will be no condensation. Then we have as well the valley climates, and they'll ask you about the slope aspect. So one of the questions which examiners love most as well, slope aspect, which refers to direction at which the sun's rays strike the Earth's surface, or direction which a slope faces. For example, we know that in the southern hemisphere, the north-facing slopes are warmer, yet the south-facing slopes are cooler. And in the northern hemisphere, the south-facing slopes are warmer and the north-facing slopes are cooler. So that is basically about the slope aspect. So we need to understand also as well the different valley wind, that is anabatic, katabatic, valley inversions, where with the inversion we look at temperatures increasing with height, that is an inversion. We have the thermal belt, which does also form at the valley inversion, where temperatures does increase with height. Then the frost pockets, which develop at the bottom of the valley as a result of the subsiding cold air. Then the radiation fog, forming when air temperature drops below the freezing point. Then as well, there are effects of settlement and farming. Like we know, if you are into farming, you have to understand that the valley bottom, it is associated with frost or cooler conditions, meaning we need to be able to plant crops that can survive in cooler conditions. Then the middle of the valley, which is our thermal belt, where it is a bit warmer, then you can plant crops that are suitable for warmer conditions. So those are some of the effects of the valley inversion. Then we go to the pollution dome as well. Define what is pollution dome, where we say an area of polluted air above the city because of the pollution dome, industrial pollution, too many cars causing pollution, etc. The effects and also the strategies. Then we proceed to question number 2. So basically, climatology or climate and weather forms part of question 1, which should be marked out of 60 marks. And it is as well very easy to score good marks in question 1 of climatology. Then proceed to question 2, which will be geomorphology, which does talk about the concepts of the drainage, the definition, identification, and application. Where they ask you, so you need to understand the various concepts. What is the drainage basin, catchment area, the system, the tributary, the confluence. So you need to understand all these concepts, because we are sure that you cannot miss 2, or the examiner won't miss to at least bring some of these concepts in exams. Then as well, to understand the different types of rivers, the permanent, which flows all the year round, periodic, flows in the period of rainfall or in a wet season. Then episodic only flows when there is an episode or when there is a heavy rainfall. And exotic does flow through dry areas. However, to understand more about the rivers, you need as well to understand the influence of the water table. Then we go to another concept, identifying the underlying rock structure, development, and the characteristics of the following patterns, the drainage patterns or the drainage systems. And by pattern here, we are looking at the appearance of rivers as viewed from the surface. That's why some rivers, they form a dendritic pattern, others trellis, rectangular, radial, centripetal, drained, and parallel. And as well, take note that the examiners, they love more of bringing a lot of this into map applications and the interpretation. More of, so they enjoy more of the geomorphology when it comes to map interpretation and application. So meaning you need to understand the appearance, or you need to know how these patterns differs from each other, their structure. So just in case they do ask you in map work, or so you are able to tell which pattern. Then we proceed to definition of the various factors. What is precipitation, evaporation, vegetation? Now, how do these going to result into influencing the drainage density? Remember, drainage density, we are referring to the total number of streams in a drainage basin, where some basins have got many streams, others have got low density. And at times, they can use the word high to refer to fine, and low to refer to coarse. So take note of that. As in case they will ask you which area has got a finite density and which area has got a coarse density. So then you got next. You need to also understand, by the way, as well, like I mentioned, examiners, they love more of geomorphology when it comes to map interpretation and application, where they could ask you density, what is causing the area to have a high density or a low density. So that is when that's when we need to understand all these factors. How do they contribute? For example, like precipitation, where we could say low precipitation causes low density, and high precipitation, that is rainfall. High precipitation got into high density. Or if you talk about vegetation, we could say sparse vegetation allows high runoff, causing a higher density, and dense vegetation does result into high water infiltrating, resulting into a low density. So in that way, so you need to understand how to differentiate how the following factors do cause a high or a low density. Then, as we need to talk about the stream order, we refer to how streams are arranged in a drainage basin, where we have the first order streams, which we refer to as the independent streams. For example, this is the first order and this is the first order. That's why we use 1 to refer to first order. And when 1 and 1 join, gonna form a second order. Then also the policy applies, where we say the order can only increase if two streams of the same order join. Two streams of the same order, for example, 1 and 1, when they join, so the order can increase to 2. But if we have 1, for example, this is 1 and this is 2. This is 1 and this is 2, so the order is not the same, therefore there will be no increase. So the order is going to remain 2, right? Then we look at the discharge of a river. we'll talk about the laminar flow and the turbulent flow as well. We say laminar flow, where a river flows over a smooth concave. Turbulent flow, where there are a lot of temporary base levels along the river course, resulting into turbulent flow. Right? Then you go to the fluvial processes. Where they ask you where we're going to look at the different types of profiles, where we have the cross profile. And as we know, a cross profile here, we are looking at the shapes of the river at different stages, like the V shape, the U shape, and wider shape. Then the longitudinal profile shows us the side view of the river from the source to the mouth. So this could be our longitudinal profile. We're seeing the side view from the source to the mouth. Then as well, you need to understand the different landforms that are associated with the river processes. For example, a meander, the different types of slopes that form in a meander. We have the undercut, which is the steepest, the slip off, which is the shallowest. So the steepest, steep, niches, shallow, the oxbow legs, the braids. So now this is another question that also the examiners they love as well in map interpretation and application. And river grading as well. Not forgetting the base levels of erosion, like the temporary and the permanent. Then we proceed to rejuvenation. What causes river rejuvenation? Different features that develop as a result of rejuvenation. Then look at the river capture, the concepts including river capture, osteopiracy, abstraction, which we know as the lowering of the watershed, type of erosion responsible for river capture. So in most cases, learners confuse headward erosion with lateral erosion. But remember, it is the headward erosion that will cause the river to erode backward through the watershed to be able now to capture the other stream. Then the different features that are associated with river capture. We have the captured stream, the captured, the misfeed, the elbow, and the wind gap. And as well, their impacts. So we need to understand what will be the impacts of river capture on areas where the river has been captured and also where the river has been added more water. So we need to understand the different. Like here they say the impact of river capture on the captured stream and the captured stream. Right. And lastly, river catchment and management. So this is another common question which the examiners as well love so much. Talk about river management, that how best do we ensure that rivers or drainage basins are not destroyed, or how do we ensure that they are well looked after, because we know South Africa is a water scarce country, so we need to ensure that drainage basins, catchment areas, or rivers are well looked after to ensure sustainability of these rivers. Then, so that basically that is geomorphology out of 60 marks. Remember, climatology 60 marks, geomorphology 60 marks. That is question 1, question 2. And question 3 is still in paper 1. It will be geographical skills and techniques, which we commonly know as map work. So remember, the structure of geography changed since 2021, where we have climate and geomorphology and map work as the paper 1, and paper 2 we have settlements, Economic Geography and map work as paper 2. So it means that we should expect map work in paper 1 and as well map work in paper 2. Right. So under map work, basically you need to understand water contour lines, the contour intervals, height, and all the different conventional signs. Don't forget that all these are always given to you on the key. For example, on topographic maps, always gonna give you a key to try to enable you to understand the different features on that map. So you need to understand the compass direction. We know that the compass has got 16 cardinal points. Some know only 4, which is north, south, east, west. Others know 8, which is northeast, southeast, southwest, northwest. As well, we have more other points, which makes them to be 16. That is the compass direction. The true bearing, here we are finding direction but in degrees, meaning you must have a protractor with you to be able to answer the question regarding the true bearing, because there will be measurements, or there will be using of a protractor, a ruler, and all that. Then the magnetic declination and magnetic bearing. Remember, you need to understand how to calculate the magnetic declination, because to get magnetic bearing, you have to know how to do true bearing and as well magnetic declination, so as to answer the magnetic bearing. Another thing that I noticed, dear candidates, when it comes to map work, you need to be very careful whilst reading these questions. Take your time to understand the questions. Nowadays, they are using English, so at times learners are missing marks because they do not read the questions to understand. So always try as much as possible to read the question carefully so as to score marks. For example, let me say calculate the area of block A2 using the length of 2 meters and the breadth 3 meters. So some learners will rush into doing measurements, yet already the examiner was able to measure and the conversions for you. So what you need is for you to just read the questions and understand it carefully, especially with map work. Then understand the different types of scales and comparing, calculating the straight line distance in reality. You can use wool, you can use a piece of paper and all that. The calculating area of regular figures in meters or kilometers, preferencing numbers or map index, or right, index sheet as well, the grid reference, the coordinates, calculations of gradient, drawing freehand cross-section, intervisibility, and exaggeration. So basically, that's about map work interpretation and application. Don't forget as well, we have GIS as part of map work, or as part of question 3. So meaning at least you need to understand the various components of GIS, how to define GIS, sources, remote sensing, resolution, pixels. So you need to understand all these different concepts. Talk about data layering, data manipulation, buffering, querying, all that. So that is about paper 1, ladies and gentlemen. So please take note. Paper 1 consists of question 1, climate and geomorphology, which is 60, climate and weather, which is 60 marks. Question 2, which is geomorphology, 60 marks. And question 3, which is map work, 30 marks. So at the end, we have a total of, this is 6 plus 6, 12 plus 6 will give us 15, which is a total of 150 marks for both paper, sorry, for paper 1. In paper 2 as well, it will be out of 150 marks, meaning at the end they're going to add paper 1 and paper 2, and they'll convert it to the given weighting for your try marks. So that is about paper 1, ladies and gentlemen. Paper 2. Paper 2. Paper 2. We're going to look at, it does include rural settlement and urban as marks. So meaning you have to read it carefully, understand the different concepts